Okay, so where we left off roughly yesterday, we talked a lot about a lot of different things. Where we're going to pick up today is talking about strings. Kind of hit the basics. What is a string? Well, a string is basically a combination of characters, anything that you can type at the keyboard. It's kind of interesting. If you didn't know, you go to Windows and look at the character map. If you ever pull up the character map, there are a lot of different symbols on a computer that you're probably not even aware are considered, valid inputs to a computer. All these different languages, obviously a lot more than English is supported, right? So looking at this character map, you even get these funny like blocks and heart symbols. And so you get this Unicode character, which is just worth pointing out. This UA741, okay? And that's this Latin small letter K with a stroke. Okay, so a combination of these characters together is considered a string. And so, the string data type can be with a lowercase s, or like everything else, there's a synonym, capital case S. My name equals Evan. Okay, pretty straightforward. We learned yesterday that with the plus symbol, you can do addition. But when you do a plus on a string, this is actually called something else. This is called concatenation. So this is to say, okay, append Evan with a space and then the word Gudmestad, it's my full name, right? So I guess the first thing to learn about strings, when you quote unquote add strings together, it's called concatenation. I one time had a student say, oh, that reminds me of Concatenus Everdeen from Hunger Games. It's like, however you got to remember it, okay? It's a funny word. It's a programming word. It means adding strings, okay? That plus symbol then, this plus symbol is known as an overloaded operator. It's overloaded because, well, if you're adding numbers, of course, you're performing addition. That's one function of the plus symbol. But when you're adding strings, you're doing this concatenation operation. So point is, depending on what you're adding, you're doing different things. You're either performing a sum of some things or you're adding strings. And then, of course, label result.text, my name. We should get the concatenated version of this of my name. And so that's kind of the first thing. Unicode, what did we call this? Unicode, small letter K with stroke. We'll just call this letter K. This is not really something I do that often, but you can, and I got to remember the syntax, using this U, \U, A741. I got to remember A741. Okay, and if I were to print this out, Unicode letter K, okay, you can actually print that symbol to, so that if there's ever a character at the character map, just realize that you can use the Unicode value that you get down here. You can all see UA741. Should you find yourself in a position you need to do that, now you know how to do that. Okay, but that's not really something that's done, I don't think, all terribly often. What else can you do with strings? We show concatenation. What happens when you add an age? Int age equals, how old am I? I think I'm 38. And what if I say my name plus equals age? Whoop. Did I just delete? Okay, I didn't mean to delete that. My name plus equals age. Does this work? Okay. So when you add a number into a string, it concatenates that number at the end. Okay, we don't do any sort of addition here. Does anyone see a problem with if I just print this out? If I print out my name at this point, obviously it's got my age in it as well. The problem that I was alluding to is that there's no space in between the end of the name and the beginning of the number. You could just put in a hard code of space right there and kind of fix that little problem. Okay, so that's adding strings together. That's adding integers into a string. And of course, if I wanted to then say my name plus equals Unicode letter K, we can add it all together. And we're getting strings. Now, a lot of times when you get a string, you might need to, and I'm not going to demonstrate all of these different methods, but you might need to perform a substring. Actually, they don't talk about substrings here. Interesting, they don't talk about substrings. A few more things that we can kind of go over quickly without code demos. You can append new lines. So if you want to force line breaks, you can put a \n. These are called escape sequences. So if you want to force a new line, I said, let's go my name. Instead of right here, I'll put a \n. You kind of see that color codes that, so that'll force the age onto the new line. So that's a nice little escape sequence that you use quite often. These other ones you don't use as much. On the hands-on test, you might have noticed that some of my output was tabbed over with a \t. That's one way of doing that. If you're representing a file path on your computer, like take a look at this file path, C:\users, so on and so forth. If I want to represent that as a string because you're working with file IO, what you need to do is you say string path equals, let me Control Z, put that in quotes, and you see it's actually pretty smart. For every single \, when I pasted that in, Visual Studio is really smart. It replaced it with a double \. The reason being is a single \ is the escape sequence. And so if and when you get into file IO, this is very common where Windows have \s in their file path. And you need to replace those \s with two \s. And then you got a single quotation mark with a \. All right. There's another way of using strings if you don't want this double back. If you don't want to do two \s every time, you can just put an @ symbol in the front, and then you can use single \s. They call this syntax a verbatim string literal. You can kind of see here, you don't need the double \ if you put the @ symbol in the front. Okay. Talked about these aliases already, covered those bases. Now, when converting data types, let's kind of comment this out. back to my form designer here. All right, let's bring in a text box. This is something I got asked a lot yesterday on the lab, which is just how do I read a value out of a text box? So let me go to the properties of that text box. And come on, Visual Studio.
It was doing that to me earlier.
Yeah, let me go ahead and exit, and I'll click on save, reboot this. And Solution Explorer. Right click, properties. Now we're good. Reboot fixes half of the problems. Okay. First common mistake that beginners make is that when they add a control, they don't name it right away. Okay? My advice, if you add a control, give it a name immediately. Don't leave this. What's the default name? The default name is textbox1. Don't leave it textbox1. You want to give this a meaningful name so that you know, what is textbox1? What is textbox2? What is textbox20? What is textbox31? No one knows. You want to give these meaningful names. So the way to do that is in the properties of the name. Now the convention is 3 letters for the control. TXT, lowercase, camel notation. So 3 letters for the control. In this case, it's a text box, so TXT. Let's just assume this is a username, okay? And just to identify that, I'm going to drag on a label right here that tells the user in a text, text, username colon. Okay, so we put a nice little label right next to the text box so we know what its purpose is. So we got text username, we got a click me button, string username equals text username dot text. Okay. Label result dot text equals username. We got strings all around, no need to convert data types. Click it, and of course we need to put something in there. If you just click it, I would anticipate that crashes it. It's interesting that it didn't. If I click it now, wow, leaving it blank. Oh, empty string. Okay, it's just putting in an empty string. Of course, that makes sense. Put in Bob. Okay. What if we also ask for an age? So let's add an label here. Let's just say age. Notice I'm not really naming my labels because I'm not accessing them programmatically. If I was going to access these labels programmatically, I'd give them a name. But my text box, I am going to access that programmatically, meaning in the C# code that I write. So I'm going to give this guy a name called txtAge. Let's click. And I'll say int age equals text age dot text. Now we learned one way to convert to an integer. What is that way that we learned to convert to an integer? Okay. That doesn't work on a string. That works in some cases, but that's not going to work on a string. How else could we convert to an int? Daniel? Yeah, you'll remember it as soon as you see it. Convert to int 32. Okay? So that int cast that you were talking about might work if you were taking like a double into an int or something like that, but it's not going to work on a string. Now let's take our label result dot text equals age to string. And it's not even doing anything with my username anymore. So if I put 38, it's just going to print out 38. Why am I talking about this? Because there's another method that you could use, and it has to do with the fact that there is an integer class that I kind of said, hey, this int is an alias for int32. There is an int32.parse. Okay, this is another way of doing the same thing. So there are these parse methods that belong to these classes like int32, like double. You could say double.parse. Okay, whatever you need to convert it into, for the purpose of this class, you just got to get comfortable converting with one method. Turns out there's just a bunch of methods. Okay, and that's what the slide deck is talking about here with this parse. Now, there's a problem with parse and converting an int, and you've probably seen this. Check this out. So if let's clean this up a little bit. I'm going to convert the text box into an int, and let's run it. And let's say the user is my daughter, and she says she's 2.5. Okay, click me, crash the program. Why does that crash the program? Well, of course, you can't put a 0.5 inside of an int. And so it says input string in an incorrect format. And so if you dig down into the details, you can kind of see that this is an exception called a format exception. And we'll learn how to fix that later on, at least in more details. There's another method of the int32 called a TryParse. Now, this is really interesting. TryParse works a little bit differently. TryParse says, okay, I'm going to try and convert the text box and this is the syntax for TryParse. And this is actually quite nice because age, now we can do, we'll use this a little bit later on. You're not needing this for your labs today, but this is just something I want to show you. Now, if I do label result.text as age2string, let's see if we put in a valid integer like 38, it prints out 38. But if I put in a 0.5, notice it just prints out 0. It no longer crashes my program. So this is a little bit, this TryParse, and we have to learn about this out keyword. So this is definitely something new for a lot of you. It's something that we will use in the future. Okay, and we'll learn a little bit more detail about what is this out keyword and how does this all work. But I just want to show you that TryParse is a little bit more friendly from keeping your program from crashing. Okay, we already talked about these convert methods. We talked about parse and TryParse, covered all those bases. We've already talked about formatting codes. In fact, we use the currency formatting code. If you want to use that here, you can still use that. So remember, $quotes, the user's age is age2string. Actually, you don't even need to do that. Right? You could still use the syntax, and if you want to format the age as currency for whatever reason, the user's age is $38. You could still use these format specifiers. Remember, I had everyone bookmark the page, and if I wanted to say percent, take this 30, take 1, convert it to a percent is 100%, 2 is 200%, 0.5 is 50%. Oh, of course, 0.5 converted to an int is 0. So there you go. You'd have to convert that to a double. Okay, this again is a different syntax for doing the same thing that I'm doing right here. Right, this is the newer syntax. That's my preference. If you want to learn the older syntax, it's in the book. Totally fine. Okay, when we come back, we don't have much of a lecture, so I'm going to send you on a short break. And we've got one more topic to talk about, which is enumerations. Well, two more topics to talk about when we come back from break. All right, let's hit pause. Okay, we're going to resume. So if you would hop back on the screen share. We're going to talk about two topics quickly. My goal is to be done by 10 o'clock. That gives you 2 hours to work in the lab. The first topic is this concept behind what's called an enumeration. And I like this concept, although I will admit we're not going to use it a ton in this class, but I do see its practical application in this. And so if we kind of stop and think about our data types, ints and doubles and strings, these are the built-in data types. There are ways to create your own data types. Okay, and in fact, when we're creating classes, which are blueprints of objects, by creating a class, that is one way of creating your own data type. That you can create instances of a class. Okay, that's called a reference type. But another way, besides creating a class, of creating your own data type, is this thing called an enum. And so notice where I'm coding here. I'm coding inside of the namespace, but outside of the class. I'm going to create this thing called enum. And, this is going to be a type of data, essentially, is what I'm going to create here. And then we're going to say what kind of values it can have. Now, the easy example for me would be, at Rankin, we've got some various rules. And one of those rules is you must have natural hair color. And so, for example, there's no blue, right? So we could, if we wanted to store information about our students, we could have a string called hair color. But if you think about a string called hair color, literally any value the user types in a text box string, hair color equals, a string can accept anything. We could put blue inside of a string, and that would technically be accepted by the compiler. Okay? And so we could make this a little bit more strict. Instead of just saying, hey, our hair color is going to be our string, we could create an enumeration, and that enumeration would only have certain acceptable values. So let's go ahead and create an enum called hair color. So again, it's done with this enum. Notice where I'm coding. Hair color, curlies. Okay. And we'll say blonde, comma, brown, or white, red, gray. Is the color gray with an A or an E? I think it's an E.
Both are acceptable.
Both are acceptable? Get out. Learn something new. Okay, so these are the acceptable hair colors at Rankin. Now when I say, hey, in my class, I want to code a hair color, I actually have hair color as a data type. Hair color, student, or maybe we call it hair color, equals, now notice the only acceptable values are hair color dot, gray, blonde, red, or white.
Not allowed to have black hair?
Sure, let's add black. But these are the acceptable values, right? So this is kind of a more strict way of accepting data, not in a loosey-goosey string that can accidentally allow bad data into it. Okay, programmatically you would allow bad data in. if you're ever familiar with bad data in, bad data out, right? Bad data in, bad data out. That's a big, problem. You want good data in, you want good data out. And so this is just kind of a way to enforce a strictness on the data. Okay? Now, you could also say that, hey, validation needs to happen on the front end and the back end. And I would agree, that needs to happen. This is just doing some validation on the back end. Okay, we're making sure we've got some good data. Not going to say that we're going to do this a ton in this class, but it is a feature of C#, and we cover it, okay? So that's that. Finally, we've got one more concept that, again, I'm going to say we're not going to use this a ton. However, this is a newer feature of C#, and we will use it later in later semesters. Okay, so it's kind of good to pay attention now and just realize that this is something that we will use in this curriculum. Okay, even though you might not use it a lot today. This is a fun term. A lot of fun terms in programming. Well, they call it, this is what I'm looking for, the Null Coalescing assignment operator. But let's kind of start here, okay, before we get into this Null Coalescing assignment operator. It's a little bit newer, so I haven't done this a lot. I have experience using this. On the surface, it's really not too complicated. Notice we've got a new symbol on our data type. That symbol is a question mark. Just by adding a question mark to our data type, we can assign the value of null. So right now, notice if I say equals null, null is not acceptable value on our integers or on a double for that fact. Now strings can be null. Okay, strings being null or acceptable. And so simply by adding the question mark that says, okay, allow this data to be null. So let's even back up. What is null? Well, null is a value that just means it doesn't exist. The data doesn't exist yet. Okay, which is different than 0. 0 is a value that exists. Like you can get a 0 on a test, right? That's a value that exists. But null is just to say the value doesn't exist yet. And so I'll tell you how I have used this when working in a web interface and the page loads and there's like a text box for the user's age. You might say that text box is null. There's no value in it, but ultimately it's going to be an int that's going to be in there. So you kind of preload this int with this nullable integer type to say, hey, basically when the page loads, accept an empty text box. Okay, so I have used this in that kind of context before. It's, again, not something we're going to use a ton in this class. Now, so that's very basic on, this is a data type that can contain a null value. Let's take it a step forward, and it says, hey, here's this null coalescing operator. And it says, hey, let's create a variable called quantity. And so this is the two question mark operator, which is different than what we just looked at. This says if there is a value in this variable called quantity, then put it in QTY. Otherwise, give it a default value of 1. It's kind of like an if-else, if you will. If there's now, if quantity is null, then QTY will be -1. However, if quantity has any acceptable value, go ahead and put that in QTY. So this null coalescing operator is the double question mark, and it doesn't exist in JavaScript. Okay, kind of the same thing. Just pointing it out, you know, null coalescing or nullish coalescing, kind of the same thing. Point is, it's in both languages, and it's a newer feature in both languages. So, you know, while we're not going to see it a ton, like immediately, it is something to be aware of, and eventually you will use it. Okay. Last thing I failed to mention here is that these are in fact constants. These are variables that are constants, and they do have numeric values. The first one is 0, second one is 1, 2, 3, 4, so on and so forth. So if I look at blonde would have a value of 0. So I could test hair color red. So I could say, you know, if hair color, which is my variable, lowercase hair color, yeah, that's right. The name hair color does not exist in the current. I think. Let's see. It's not playing nice with me right now. It's acting like it doesn't exist. It is a field. It is right there. It does say read only. Well, because it's constant, we can't change it. That's the idea. Because it's constant, we can't change it. Oh, there we go. My hair. I just needed to do it back here. Okay. You can't change the acceptable values, but I just needed to put this in executable line of code. Okay, there we go. Now that's working. What am I demonstrating? So I could say if my hair color equals, I believe we should be able to test it against an integer value. Well, my hair color is red, which has an integer value of 0, 1, 2, 3. So that might not be that useful, but in this case, it's like, hey, if I got net 30 days, I could say if the terms value equals 30, else if it equals 60, else if it equals 90. So you can use numeric values for these acceptable constants. Okay. All right. Stopping here, that's really the end of lecture for chapter 4. We've covered all the nitty-gritty in there, and believe me, there's a lot of nitty-gritty. We're going to have the rest of today for lab, and then tomorrow's going to be another lecture, more lab. We continue on.